Excellent. So today's content, now some of the days, there's a couple things I wanted to cover that I kind of forgot to cover on our very first day. Only one of which I can remember at the moment. Most of you, part of the reason you made it here, not into this classroom, but like to BYU, you made it into post-secondary education, is because you have a talent for memorizing stuff. Like everything until you hit high school, that's what learning was memorization. Once you get into high school, maybe a little bit in your junior high school, but once you get into high school, you start doing abstract reasoning. So to get here, you also had to have abstract reasoning skills because that's what makes you perform well in high school. But this is a class that memorization is going to help you almost none at all. In fact, I had a student recently who was like a medical professional, and like he was like great at memorizing. And this class, like he was really, really good at a lot of education, and he really, really struggled in this class. And the reason is that in all of his education to get him where he was, it was like memorize this set of information. There's like this set of symptoms that's going to predict this particular kind of diagnosis. Memorize all that, see it, apply these rules. It gives you this output. And that kind of problem is what we refer to as a well-formed problem. Give an initial state and an algorithm, you'll produce the end state. Like that is, I already asked my fellow accounting students to identify themselves. But through all of my accounting career, I got the master. I was in the MAC here, graduated with the MAC. That describes 90% of the accounting classes I took. It was, you've got some starting state, learn the rules that you apply to that starting state, and it produces the correct ending state. And that simply does not work in this class. In this class, it's the opposite. You've got some starting state, which is usually a blank worksheet, and you've got some ending state that you know what it's going to be like. You've got some description about what this thing has to do. There are no rules that you can apply to just get there. You've got to like figure it out. Like in accounting, it would be analogous to, you got to make up the rules every time you do it. You got to make up new rules to apply to this starting state to get to the ending state. If you do that in accounting, what would happen to you? You'd go to jail, right? So it's really, really different. And so it's just kind of a warning as we're coming into this, is what really got you here, where you are, is not the main skills that are going to make you succeed in this class. And so anyway, just kind of a warning, and think it's a really, really creative endeavor, because you got to think, I don't know how to do it. Professor Allen showed me some tools, but I don't really know how to apply. They got to come up with this on my own. But here's the good news. You are all creators. How do I know that? Because you are sons and daughters of the Creator. And so you have it in you to do this. Like there's no one who gets admitted to BYU who can't do this, but it may be a different way of thinking than you've had to think before. Now, most of the times when we come to lecture, how it's going to be is we're going to start with a workbook, and I'm going to say, hey, let's do something great and interesting. I'll teach you some new stuff today and how to program with VBA. Sometimes we'll be like building a tool that's like useful, and you'll be like, oh wow, I'm going to take the example from class today and I'm going to go use it. That doesn't happen all that often. Other times there'll be like little disparate examples that kind of show you different little parts of it. Very rarely, in fact, I think today is probably the only day, is this going to feel like a normal lecture where we do a lot of talking and a little tiny bit of coding. But that's today, and that's to understand some of the one place that you might be doing some memorization here is in the stuff that we're learning today. Now, in the chapter that talks about like expressions and variables, I think the chapter does a pretty good job. But I want to help you understand variables a little more deeply. I think in most of the education that we do, at least here in the business school for sure, I don't know what it's like over in computer science, we'll teach you about variables metaphorically. We'll say, oh, a variable is like something, it's like something. I'm going to help you understand really what a variable is, and hopefully that'll be kind of a good foundation for your work in this space. Now, when I look at a computer, the physical hardware of a computer, there is one place that I can store a value, and I can have that readily accessible to be able to do some computations on. Now, if any of you are like engineers, you're going to come up with another place that I'm not talking about that meets that. But what is that place called? What's the place called where I can store a piece of information and have it readily available to kind of pull back in to be able to do some processing on, set it aside again? A little bit louder? Yeah, memory, random access memory. So it's RAM. And if we look at a computer, there's a beautiful computer that we have right here. This is a Dell. What is this? Dell XPS. How long have you had it? Oh, 3 years. Do you know how much memory you have on it? Oh, I don't even know. Who could tell me how much memory they have on their laptop? Go ahead. How much you got? Oh, you have 32 gigabytes of memory. Wow, that's a lot. I have 32 on my desktop machine. And every once in a while, I mean, I have like hundreds of windows open. Every once in a while, I'll pop open the memory to see how much am I using. I'm using like half of it. Oh, I got to open some more windows. So yeah, so like that's a huge, huge amount of memory. And that's a great machine. Don't lose it. Don't hit him on the head or whatever. It's someone else. I think he meant 32 megabytes. It's an old one. You don't want that one. So it's like the place where you can say, listen, you know, and we refer to it as volatile memory, right? Because you lose the power and that just bleeds away. It's got to have active power to it. Right now, if you want to stay around even without power, that stable storage, your hard disk, maybe it's a spinning platter drive. More likely today, it's a secure SSD. What's it called? SSD, solid state drive. Thank you. But memory is the important one. So when we're programming, there's going to be lots of times where we're saying, all right, we've got to keep track of lots of different things here. And we're going to do something over here for a little while, and then we're going to do something with something else. And that value that we've figured out, we're going to set aside and bring it back later. That value that we've asked the user to type in somewhere, we're going to set it aside, but we're going to bring it back later. And so that's all in dealing with RAM. Like this is like old school memory chip, what it looks like. They don't look all that different today. And so, you know, inside of that, you've got 32 gigabytes. So we'll talk about that. That's like incomprehensibly large to think about how much that is. Ultimately, everything that we store, like in this little chip, has to be expressed in binary notation. It has to be down to either a 1 or a 0. Like we think of worksheets and rows and columns and names, and all of that has to be converted all the way down to 1s and 0s for us to be able to store it here and then be able to pull it back. And so that's what we use variables for. And if we look right here, if we could kind of like peek into that chip, it wouldn't really look like 1s and 0s, but this is going to be our way to think about it. Like it's just like one continuous set of 1s and 0s. And we would look at I guess we'll look at that picture again here in this moment. So we need to have some way to be able to access that fast set of on and off switches or 1s and 0s to be able to store information. And believe me, folks, you don't want to think about those in 1s and 0s. And so variables allow us to put stuff into memory, pull stuff back out of memory without having to go all the way down to 1s and 0s. VBA is going to handle the 1 and 0-ness of this for us. So here's the definition of a variable. So a variable is a location in memory. So a variable is a location in memory with a name. And that's the important part. It's a named location in memory. Variable is going to be of a specific data type. Oh, I'm sorry, where a value of a particular data type can be stored and retrieved. So the idea here is we say, listen, we've got this vast amount, 32 gigabytes of data, an unbelievable number of 1s and 0s. Somehow we've got to find a particular place in all those 1s and 0s and say, I'm going to put a value in that little place. And then 10 minutes later, I got to say, hey, what was that value that I set aside? I need to bring it back to work on it. We'll be able to pull that out of memory. And so all those 1s and 0s are what we refer to as bits. Bit is short for binary digit. The smallest amount of memory that we're going to ever refer to in VBA is going to be a byte. It's going to be a set of 8 bits. And so that's just a little lingo for us here. So if I was to have a 1 byte number, I've allocated 1 byte of RAM. And so here, let me see if I can get my little laser pointer going. So here's my 8 bits. I'm going to think about this in terms of storing just a numeric value here. And here's how I would store 0. Like in all of those bits, I would store 0. Now, what I'm saying is that this bit right here represents how many 1s I have. This is how many 2s I have. This is how many 4s I have, how many 128s I have. So if I was to say I have 1, what number does this represent? That's 1. So how do I represent 2? Yeah, 1, 0, right? I have 1, 2. How many 1s? No one's just adding up. How many? I'm multiplying this number by this number. I'm taking the sum product. If I had Excel around, I just take the sum product of these two ranges. So in fact, that's 2 in binary notation. You may remember this T-shirt. There are that many types of people in the world: those who understand binary and those who don't. This is another version that I'd seen somewhere, but I couldn't find the picture, but I had to kind of hack it in here. There are 2 types of people in the world: those who understand binary and those who have friends. I don't know. I took offense to that, but here is, so here's 3. What does that say? It says it's got 1, 2, it's got 1, 1, it's got 0, 4, 0, 8, 0, 16s. There's 4. There's what? 65. There's what? Someone yell it out when you got it. 255. You do that so fast. You had to add up 128, 64, 32, 60. You're like the walking calculator. Who did that? How did you do it? What you did was you said, let me just look at this pattern. This number doubles each time. And so what would the next number be here? It'd be 256, right? So if I tried to, if I went 1 more up, there'd be 1 256, and these would all go back down to 0. So this has to be 1 less than that next number. Yeah. So that is the highest value that we could put. It's the highest value that we could put in there. It's 255. What happens if I only have 1 byte for keeping track of a number, and I wanted to go larger? What would happen? What would happen if I tried to cram another 1 in there? It would overflow. Oh yeah, your cup, my byte runneth over, right? In fact, here, let me just go ahead and open up Excel. I don't know what that means, but I got it. And Alt F11. Okay, so here I'm just going to, so here, if you can do this along with me if you want. I don't think you get that much benefit from actually running your fingers over this. It's probably better off to just kind of watch and focus on what I'm doing. But you could get here by choosing Developer, Visual Basic. That would bring up this window. Now, when we recorded our macro last time we got together, we saw the code that it generated. There's no module to hold that. If we started recording again, it would make a module for us, but I'm starting from scratch, so I'm going to choose Insert, Module. And the module is the place that I put VBA code that it's going to stay with the workbook. So when I save the workbook, my module gets saved along with it. It's the code that's here to stay. Now, when we recorded that macro last time, it started off by saying sub. It gave it some name. And then it ended with end sub. Okay, so here's how we actually declare a variable. We say dim, D-I-M. I give it a name. I'm going to call it here, I'm going to call it num var. It's my number variable. And then I give it a type. And the type I'm going to choose is byte. Kind of a weird type. This is a 1 byte integer. That here. So that means, what am I allowed to put? Could I put a capital A in this? No, I can only put numbers. And could I put 1.5 in this? No, it's an integer. And what's the range that I can put in this? What's the biggest number I can put in? 255, the smallest? 0, yeah. So watch what happens here. Let me just say, hey, I'm going to go ahead and put something in here, and here's how I do an assignment. Here's how I put a value into that location in memory. By putting this statement here, it tells the interpreter, hey, when you start running this, go allocate some memory. And what the interpreter says, it says, listen, operating system, I need some memory. And the operating system says, all right, here's some memory. Here's a location that you own. And interpreter then is going to keep track of the address. The operating system gives the address back to VBA. And VBA is like, okay, I know my user doesn't really want to know what memory address that is. So it's going to say, I'm going to keep track of the connection between the name of the variable and the location in memory. So I only have to, I don't care where it's in memory. I couldn't care less. All I know is that, hey, I asked for some memory, that got allocated, and I'm going to call it this. So if I want to put something in memory, I'm going to say, that's how I say it. I say let var, numvar equal 5. And I love this because it's like the voice of God. Let numvar equal 5. And it does. The truth is, we get tired of writing let all the time, and so it's optional. You don't have to put let, but you can. Like if you want to feel godly, let numvar equal 5. Okay, now let me do debug.print. This is the debug object. Oh, probably should just refer. Right at the very end of a class last time, we talked about objects. We said there were 2 characteristics of objects that are going to be really important to us. Who can remember what one of those characteristics is called? Objects have a property. And what's a property? It's just a value that tells me something about the way the object is. So property is the one, and the other one is objects have methods. And a method is something the object knows how to do. And so there's this object called debug that we use for debugging, like when we're developing code. You don't ever have your user do anything that is the output from this, but while you're developing, you do that. And it has a method called print that will just display whatever I tell it to display. Like I can say print 55. And in my immediate window, you can get this immediate window to show by choosing view immediate window. And debug.print will just print that to the immediate window. So I said print 55, it puts 55 right here. But what I really want to do is I want to print numvar. And it knows I don't really want to print like numvar. It's going to show me the value that's in memory at the location that has the nickname numvar. And so what do we expect that to print when I run it? That should print 5. Should be on it when I click play, and that will print 5. Now I should be able to do 255. Run it again. Run it again, 255. But what happens if I say 256? Watch the error message. Overflow, like it really is. You tried to cram another one in there. There's no more room, and that byte overflowed. Like you now have a bit rolling around on the inside of your computer. If you shake it, you'll be like, oh yeah, I can hear that bit in there. Not really, that's a joke. Apparently not a very good joke, but bits don't actually fall off those chips. But the point is, there's just no more room for it. So what happens if I try to put something that's too small? Right, I should be able to put in 0, run that. 0, that's fine. What's too small? -1. Should it be an underflow? I think it should be an underflow, but it's still an overflow. What overflow means is you tried to put something into that allocated memory that doesn't fit. I can't do. If I did put it in, it would overflow. And so VBA said, I'm not going to do it. This one's a little bit interesting. Let me put in 5.51. What's that going to do? Error? Bing. Oops. Bing. No error at all. A respectable programming language would have given me an error. You're trying to put 5.51 into this one byte, and you can't fit it in. That should be an overflow in most other languages. Well, in most other strongly typed languages. But the philosophy behind VBA is kind of a philosophy about Microsoft in general is like, listen, we're trying to make this stuff usable to the masses. And so if you've given me something that can't work, before I give up, I'm going to try to do as close as I can. And that sometimes is a problem, especially if you think, I didn't really realize I thought I was giving you something you could do. And so just realize that anytime we're dealing with variables, if you give it a value that just isn't quite going to fit, VBA might say, well, kind of close, I'll make it fit. Watch this one. Now, the way that we go back to 5 here for a second. And instead of printing numvar, we just print a string literal. I think we talked about this. Did we talk about this yet? Maybe we didn't. So a string literal, or sometimes called a string constant, just says I put it in double quotes, and that's a string. We'll talk about the data type here in just a minute. It's just characters. So I'm going to run this. Give myself a little more room in that window. It actually prints, hi there. So let me put into this a string. This is a string with no, that's a string with a couple of spaces. That's a string with one space. That's a string with no space. That is a string with no characters in it. What is that going to do? You might think that's got to be like a type mismatch or something. Oh, type mismatch. I thought that was going to work. Never mind. Pay no attention to the man behind the curtain. We'll talk about when this works, this little thing works elsewise. Sometimes VBA will be like, oh, that's a zero length string. Let's do it this way. Hold on a second. Let me just refer to a particular cell, A1. What's in A1? What's in A1? Yeah, nothing. But when I run that, it's going to go, oh, you must mean zero. It's not zero over there, but it's like, it's an empty cell. Zero is as close as I can get. Before I give up, I'm going to say, let's call it zero. So some strange things. Go ahead. Yeah, I was expecting the empty string to do it because that's really what this is an empty string. Like if I ask, does A1 equal an empty string? The answer is yes, or equal to each other. So when it brings in, like when I assign A1 to the variable, it's able to do the conversion to zero, but it doesn't with the string. I kind of thought it would. I don't go around assigning zero length strings to my variables all that often. Okay. Other questions? Okay, so what if I had 2 bytes instead of 1 byte? Does that mean I should be able to hold twice as much information? My number should be able to go twice as large, right? I've got twice as much memory. I should be able to hold a number twice as large, right? Wrong. Why? Because it doubles with every additional bit. Every bit I add doubles it, right? So, that's what 256 would look like. One more. These all go to 0. There's 256. And then I add another bit. I get to 512 and so forth. So 256. What is that? Looks like about 1,000, only because I made the slides. And we have a data type called byte, and that's what it is. So there's a type called byte. It holds integers, range 0 to 255. Here's 2 byte. There's a data type called integer, and that's what it is. It's 2 bytes. Now, the range for integer is a little bit different because instead of starting at 0, we'll come back and talk about what the range for integer is here in just a second. So we've already seen how to declare a variable. And what I'm showing you here in this diagram is I'm saying, listen, there's some of this memory that's like available for use. It is the memory that's not gray. Other of this memory out here has been allocated to different programs. Now, when that memory gets allocated in the first place, it usually gets allocated contiguously. But what's going to happen? I was doing some stuff in Microsoft Word, and I had a bunch of memory allocated for it. I closed Word. In the meantime, the operating system gave memory to other programs. But once I closed Word, it's like, oh, all that memory that we're using for Word, gone. I can just free that up. It's now available for other things. So memory ends up being like this, kind of scattered around where some over here is reserved. It's, some programs using this, some programs using this. It's the responsibility of the operating system, once it gives like this block of memory to VBA, to make sure no other program even tries to access it. What would happen if another program tried to like bypass the operating system, tried to access that memory directly? It's the responsibility of the operating system to terminate that program and kill it hard. It doesn't happen as much as it used to. Like when I was a student and Windows was pretty new, like if you made it like through a day without Windows just crashing and stopping, that was a good day. You think I'm joking? I'm not joking. And the main reason that happened was because, well, I don't think it would stop all of Windows, but like your application would die. Is because your application tried to access some memory it wasn't supposed to access, and Windows just killed it. Boom, you're right in the middle, just about ready to hit the save button, and boom, it's dead. Because the operating system says you're not allowed to touch it if I didn't give it to you. Now I think the environment is you can't touch. There's no way for you to get to it if Windows didn't give it to you. Okay, but every single one of these ones and zeros has an address. So there's the address of that location in memory. And I'm just showing that address in 2 different ways. One is in base 10 notation. One is in base 16 notation, which we call what? Base 16 is also called hexadecimal. I don't know why it's called hexadecimal, but the idea is you have, instead of having 10 digits to work with, you have 16 digits to work with. So it lets you, and because 16 is a power of 2, it makes converting between binary and hex a lot easier. So we almost always talk about memory addresses in hexadecimal notation. Those two little bits are right next to each other. So you can see their numbers are off by just 1. That's whatever this long number is, 48. That's whatever this long number is, 49. That's whatever this hex number is, 0. Whatever this hex number is, 1. And so when I say dim x as integer, what I'm doing is I'm saying to the operating system, I need 2 bytes of memory. The operating system says, I'm going to find 2 bytes of memory that are not being used, and I'm going to give them to you. There's the address. It hands the address of those 2 bytes back to VBA. VBA is now going to remember x is at that location, starts at that location, and it's 2 bytes long. I don't ever have to think of it except for the name x. And VBA handles the rest of it for me. So how do we handle a negative value? Here's the idea. We're gonna store, like for those 2 bytes, we're gonna store an integer. There's no minus sign involved. We're gonna store an integer. But with the byte data type, we start counting at 0. The smallest value we have is 0. For the integer data type, which can handle both positive and negative numbers, we're going to start counting way below 0. So I'm going to start here where if I just look at the representation of this, 512 plus 256 plus 128 plus all these other numbers is 1,000. Like that's the integer that's stored in this memory, but the integer data type starts counting at negative 32,768. So we go all the way down to negative 32,768. We add 1,000, and the number then that is actually represented there is negative 31,768. That's just to be able to give us some negative numbers to work with. So here's this one where the number that's stored is 32,767. Well, we start at negative 32,768. We add that to it, and we get negative 1. Right? So the first bit is not filled. The rest of them are filled all the way up. What does 0 look like? Yeah, 0 looks like a 1 with everything else then as zeros. So sometimes this will be referred to as the sign bit because you can tell the sign of the number. If you could just look at one bit, you could know, oh, if that's a 1, it's either 0 or positive. If it's a 0, it's a negative number. But we never address a single bit in VBA. Like this is more like computer science stuff. What is that? 33,768. That's going to be 1,000. Okay, questions? That's the biggest number that I can store, but I start counting way below at 3,768. That means it goes all the way up to 32,767. That's the range. That's why it starts counting at a weird place, is to kind of roughly split it between positive and negative numbers. So the data type integer has that range, 32,768. Anyway, it has that range. Now, you might be wondering, do I have that on the next slide? You might be wondering, how specific are you going to need to learn this stuff, like for the midterm? And you're going to need to learn some stuff about variables for the midterm. But you don't have to memorize that range. I will expect you to know that integer data type holds integers, and it's roughly plus or minus 32,000. You can't put a huge number into an integer. So that's what I want you to know. So like memorizing that down to the very digit, not a big deal. That doesn't help me be a better programmer, but knowing, oh, I can pick the right data type for the kind of size of data that I want, that's going to be helpful. Okay, the next integer type. So we've seen 2 integer types. We've seen byte and integer. There's another one called long, and it's a long integer. It's 4 bytes. So it has a range of plus or minus 2 billion. So how do we do a decimal value then? There's a couple of different ways. The first way that it does it is by saying, listen, we're going to store an integer. In fact, the way VBA stores anything, the way any computer stores anything, it stores an integer. That's all it can ever store, right? Because all it can store is ones and zeros. 1 is an integer, 0 is an integer. These are integers. So everything is always stored as an integer. But because if we know the data type, we could say, well, we always want this number to be stored to like 4 digits of precision. And so whatever number is stored, whatever integer is stored, we'll just divide it by 10,000. So if I store the number 600, if I store that number divided by 10,000, that would be the actual number that that variable is holding. Like the underlying integer is this long number, but this data type says read whatever's in memory and then divide it by 10,000 to get the actual number that we're after. Question?
So about the I typed 6.55 C5 in like VBA's memory. That is what it would look like in binary.
That's what it would look like in binary. Yeah, you never see it in binary. And the data type that does this is actually 4 bytes, not 2 bytes. So it's not, this is kind of a simplified example. But right. I'll tell you about the type here in just a second. So here's another number, 52,500 is actually 5.25. The data type is called currency. Oh, it's not a 4-byte number, it's an 8-byte number. And it's roughly plus or minus 922 billion. So that can handle the national debt, right? Like not even close. Not even close. By the way, that's a pretty big number. In fact, I think this is like the largest number that this data type is the largest number that we can have that kind of precision with. You might be able to do that with double. We'll see that here in just a second. So the first option is just to know there's an integer and it's got 4 decimals, and that's the currency type. The other option is to say, you know what, we're going to use a part of the memory that's allocated to keep track where the decimal is. And then the rest will be used to keep the number. So if I had this 2-byte number, I could say I'm going to use these 4 bytes right here to indicate where the decimal place goes. And so in this representation, we're saying there are 0 digits to the right of the decimal. And so I've got then this other space left to be able to figure out the number. So in this case, that's the actual number that's being stored. But if I say I've got 1 digit to the right, like it's the same number, but I've just moved the decimal place. I could move the decimal place, move the decimal place. I could move the decimal place that far. Okay, so this is referred to as a floating point number. Have you heard the term floating point number before? That's why it's called a floating point number, is because I store an integer, I store 2 integers. One that's all the digits I need to work with, and the second one is where does the decimal place go? We have 2 types of these floating point numbers in VBA. One is called single. It's short for single precision floating point number. You should be glad it's called single, so you don't have to type out single precision floating point number. It's 4 bytes, and it has 7 significant digits. I mean, look at that. That's a really, really long number, but realize I've got a pretty long matrix that I can push. I can say the decimal either goes one way really big, or it can go to the left a big number, it can go to the right a big number. So I could either have a huge number with no digits of precision. I can have a really, really precise number, a much more precise number, a really, really small number out to several digits, but not a very big number because I've got a fixed number of digits that I'm working with, and then I can just push the decimal place one way or the other. So that's a single precision floating point number. That's one I want you to be familiar with. There's a double precision floating point number. And so, you've got, finally, I think we have enough to handle the national debt. I think that barely covers the national debt. But again, you only have precision to 15 significant digits. So again, you can push that decimal place out a long way, but you can't fill all these in with actual numbers because there's not that much memory for it. So it turns out the actual implementation of that floating point number is a little bit different in VBA, but this will give you the idea. Okay, another data type, true or false. How do we represent true or false? We store a 0 to mean false and a -1 to mean true. And that data type is called, it's called Boolean. Why does it, and it takes 2 bytes to do it. That's crazy to me. Why does it take 2 bytes? It's only 1 bit and we use 2 bytes for it. I don't know, but it takes 2 bytes. That data type is called Boolean. It takes 2 bytes and it's true or false. I think the reason because it's -1 or 0 is because that's just what the underlying value would be if I had a 2-byte number and I'm just flipping the sign bit. It's going to go between -1 and 0. That's actually what that would be. -1, 0. I always thought, wouldn't it make more sense to be 1? And yeah, but I think it's because of the underlying implementation, they have it be -1. Okay, so that type is called Boolean. Isn't that a crazy name? I remember when I first learned that word, Boolean. I said it a few times and I thought that word doesn't even make sense. Do you know where it comes from? There's a mathematician, it's an 18th century mathematician by the name of George Boole that was one of the pioneers on thinking about, what would it mean if we said true and true, true or true, true exclusive or and, did all these operations on logical, what we call now Boolean logic. It's named after him. It's his name. Okay, how do we represent dates? We store the number of days before or after an initial date, and that date is December 30th, 1899. It's a great day, isn't it? So if I store that number, 2,794, and I say, hey, this is a date type, then when we read the value, we say, oh, okay, you read the initial value. We're adding it on to our initial date, and that gives us July 4th, 1976. So how about date time value? Same thing, except instead of just storing the number of days, you're doing the fractional number of days. So if I'm saying, oh, we're storing not the number 27,958, 27,958.375. What's 0.375 into a day, starting with midnight, the very first instant of a day, plus 0.375? That's 9 a.m. And so dates and times are just a certain number of days from an initial date. And what's the range? I don't know if I tell a range on this. Interesting. It's midnight on the day, January 1st, the year 100, up until 12/31/9999. I think they must have done something extra. I would be crazy if that's actually the natural limit of that. It must have been constrained a little bit more to make it more simple to understand what the constraints are. So that's the date type. So how do we represent names? How do we get them? Those are all numerics, right? Well, dates, I guess, are something different than numerics, but how do we get there? And the answer is each character is mapped to a number between 0 and 255. So here, I'm going to take 1 byte, and I'm going to say, that's 65. 65 is capital A. So again, when I say I want to be able to read that memory, it goes out and it reads the number, but because it knows the type, because it knows the data type of the variable, once it reads the number, it goes, oh, I got to convert this into a character, and I know that character number 65 is capital A. And so I'm going to take that byte, I'm going to turn it on its end so we can fit more of them on the screen. You see how that's the same? It's just moving the numbers. So if I was going to store the string of characters, Adams, comma, space, John, the first character, those bits right there, 65. This one is character number 100. That's lowercase d. Here's character number 97. It's lowercase a. Lowercase m is 109. Space is 32. Comma is 44. And so it would store this block of data in memory. But when it gets read out of memory, the interpreter goes, oh, I remember making this variable. It's a string. I'm going to go to the ASCII table and look up all those values. Is the ASCII table next time? I'm going to go to the ASCII table and look up all those values. The first number that I saw was A, capital A, and so it's 65. Next one was, what was it? 100. So I'm going to look up 100 on this chart and find 100, and it's lowercase d. So this is the first 128 characters of the ASCII table. And these are the ones that are standard. Ones between 128 and 255 are different from operating system to operating system. Have you ever looked at a web page and you bring up the web page and it's got question marks or crazy characters that don't belong? It's because it's some character kind of outside of that standard range that got miscoded from one system to another. Yeah.
But how does the computer know what type of variable it is? Because don't they have to store that also in binary?
The question is, where does it, how does it know the type? And the answer is that when I declare it here as byte, then yeah, it's going to remember it. It must remember it in memory somewhere. And exactly how and where it does that, I don't know. But yeah, the VBA interpreter is saying, oh yeah, I remember when I access that data, I'm treating it as a byte, or I'm treating it as a string when it comes back. So yeah, so when you say it takes that much memory to allocate it, it's going to take a little bit more because it also has to remember what the type is. So there's 65. Now, all the types that we've talked about before this, Boolean, integer, byte, single, double, long, currency, all of these are what we would call as fixed length variables. When I allocate the memory and I say dim x as integer, the interpreter knows I have 2 bytes and that's it. If I try to put something larger in that, the answer is no. Strings are different because strings can be so variable in length. A string is what we refer to as a variable length data type. So we have to allocate more memory to know how long the variable is. So if we look here, we have the same memory that's used to store which characters these are, but every string has 4 bytes of overhead that says how long the string is. So in other words, it is start at a particular location in memory and then read this many more bytes. What is that? 8, 9, 10, 11. So this part here tells me start at where the memory is, read the first 4 bytes, that tells me how much more to read the next 11 bytes, that's the string that we're after. And then it translates it and brings it back. And so you've got this 4 bytes that is just used for housekeeping to keep track of how long the memory is. As a result, every time in VBA that I change a variable, or every time that I change a string variable, and I say, maybe this is called name equals John, Adams. If I have name equals something else, it's actually going to not change that memory. It's going to go say, hey, I need some more memory, allocate more memory, and put the new value in that location in memory and move the variable to point at the new location. So in the vast majority of programming languages, for sure in JavaScript, for sure in Python, as I've been working with those lately, strings are immutable, which means there's no other, but that's the way strings work. You change a string, when you set a string, you can't change it. Like when you give it a new value, it has to write it again. VBA strings are mutable. Like you can actually, this isn't doing it, but there's a way for you to say, you know what, I want to go just change that one character in this string without rewriting the whole thing. It's beyond what we're doing. In fact, I've never told any class that before, and I wonder why I just told you. There's probably more than you wanted to hear. Anyway, the point is that when you give it a new value, it goes to a different location in memory. And for that reason, working with strings can be kind of inefficient. If you've got large strings, if you've got some process where you're saying, I'm doing something and adding a little more onto the string, add a little more onto the string, and it gets big, it's going to run kind of slow because every time you add a little bit more to it, you're not just allocating a little bit more memory, you're reallocating all the memory. Okay, so you got, so the length is 4 bytes plus 1 byte per character. And yeah, so, right, if we allocated this, we'd say, there's your string, what you get to have, there's the 4 bytes. And in fact, when I first declare this, here's the important part. When I first declare the variable, the VBA interpreter says, hey, I need 4 bytes, right? Because 4 bytes would be a string with how many characters? So if I think about, if I have a string variable that uses 4 bytes of memory, how many characters does that string have? 0, because the first 4 bytes are saying how long it is, and it takes those 4 bytes to say 0 characters. So the interpreter says, hey, read those 4 bytes. What's the number? The number is 0. Don't read anymore. So it's a little bit weird because when you first allocate it, it gets allocated in a place where it knows it can't stay, but it still allocates it. Then later, when you say like name equals Adams John, could I, even if I wanted to, could I fit Adams John in here? Like this is allocated to some other program. Could it fit? No. So what happens when I do that? It goes, oh, we better find some other place where it can fit. And it will like allocate that and say, that's where this variable binds onto. You know, for extra credit, it would be good for someone to actually go through all those numbers and see, does it really say Adams, John on that? You'll find out that it does. And so now, after doing that, it has rebound the variable onto that new location where it got sent to. Okay, another data type. Folks, for years, I have taught this class at a time when it got out when the big hand was on the 3. So we must get out when the big hand is on the 9. Is that right? Or no, when do we get out? You got a while to go? Okay. It'll take me a few more days to get used to that. Another data type called object. Whew, the object data type. So far, all the data types we talked to up to this point, they're all fixed length except for string. String's variable length. And so it changes every time you set the value, it changes where it moves around in memory. So string's a little more complex. Object is even more complex. So remember, an object, we talked about objects last time we were together. An object is, it's like a thing, has these two characteristics, properties and methods. So we're going to think about the properties now. So what the properties are of an object variable is they're just like all different kinds of variables kind of collected into one thing. Let me think about this object. This is like A2's range. A2's range has lots of different properties. It has an address property. It's got a formula property. It's got a value property, column, a row. There's dozens of properties that it has. But those are all located in a contiguous block of memory. When I say, oh, here, where's range? If I could look into memory and see where range A2 was, all these variables would be right there together. We can declare variables of type object, but we are not like making these complex things. An object variable is just a reference to an existing object that's already somewhere in memory. Let's take a look. So got an object variable. So if I was to dim RNG as an object, like somewhere in memory, this thing is located. And all we're saying is we are going to keep track of where that location is. So this thing is located in memory at this memory address. When we declare an object variable, all we say is, oh, we're going to keep track of that memory address. So let's see what this means in terms of our code here. I'm going to just comment these out. Let me dim RNG as an object. And then here's the next syntax, set RNG equal to this. Remember how for primitive types, we say let x equal 5. For object variables, we say set, and it is not optional. You have to say set RNG equal to range A2. Now, what this does now, print, is it makes RNG a nickname for range A2. So anything I could say after range A2, like I want to show its address, I can now say to range. Because all this variable is it is enough memory to keep track of a memory address. This is not another range object that I've created. I'm just saying somewhere out there is a range object in memory. I want to remember where it is so that I can refer to it this way. By the way, when I just say range A2, how many range A2s are there in a worksheet? Oh, sorry. How many range A2s are there in a workbook? As many as I have worksheets. So there could be 3. In fact, how many are there in my workbook? There's only 1. Sorry, there's 3. Okay, so which one do I mean? How does it know? There's 3 of them. How does it know which one I mean? It must be whatever is the active sheet. Okay, so it may be longer to get to this. It may be, oh, I got to tell it, no, I want worksheets. We'll see how to, we'll learn this syntax here pretty soon. I want the worksheets. I'm sorry, out of all the worksheets, I want the one called sheet 2. So I don't have to type that all the time. And so I can just give it a nickname. By the way, how many A2s do I have open? It's not a trick question. How many do I have open right now? 3. Now how many do I have open? 4. Yeah, I got 2 different workbooks. So I might have to tell which workbook I'm interested in. Oh boy. Out of all the workbooks. Workbooks. one called book 2, the one called book 1. I think I've got the syntax right there. Go ahead and run that and make sure it runs. Yeah, so it's still able to figure that one out. Ah. Can I have 2 copies of Excel open simultaneously? Yeah, it's kind of hard to get. It's like doesn't happen naturally. But I could have like 2 different instances of Excel. So it's not enough to say the workbook. I might have to tell it which instance of Excel I'm talking about, which workbook in that instance, which sheet on that instance, which cell on that sheet. It could be really, really long. And so one of the things that object variables are nice for is to be able to say, you know what, I just want to have a shorter way to refer to that cell. So I bind range onto this one, and it will refer to that cell thenceforth and forever. Interestingly, if I was to bind it on this way, this would be whichever one is the active sheet on the active workbook in the current instance of Excel. What happens if I was to, let's do this. Let me print, we'll just do it. Range dot parent. What do you think the parent of the range is? It's the worksheet that holds it, and that's going to have a name. So that should show me the name of the worksheet where that range is. So that's on sheet 3. Now let me go ahead and activate sheet 1. So worksheets, sheet 1, dot activate. And then print the name of the range again. Now, this is going to print one of the 2 things. It's either going to print sheet 3, or it's going to print, it's definitely going to print sheet 3 on the first one. This one's going to print either sheet 3 or sheet 1. Let's vote. Who says that's going to print sheet 3 both times? Who says, no, it's going to print sheet 3 the first time, sheet 1 the second time? Oh, and a lot of us aren't showing up to the polls today, I see. Now, I might have a syntax error here, and some of you are going, no, it's not going to run at all because it won't run at all. Let's find out. Yeah, it prints sheet 3 both times because what this is not a synonym for this expression. It's not a synonym for active sheet range A2. This will figure out which location in memory that determines at that point, and it binds that variable onto that location in memory. And so changing the active sheet has nothing to do with where that's located. It's only trying to figure out what the active sheet is the first time that it runs this, because it then says, I found that location in memory. We're going to remember that location in memory, and range is going to just, it just holds the memory address. So that when I say range, the interpreter says, oh, this is an object variable. You don't really want what's here. You want what's at the location that is stored in this location here. Like a 2-hop to get to what you're after. Of all the variables, the object type is the most difficult. And so if you're looking at this, in fact, let me just go ahead and ask, show me how comfortable you are with object variables on a scale of 0 to 5. If you're on a 5 here, you've taken this class before. How did you get here? I would expect you to be at a 1, maybe a 2. This is kind of complex stuff. So we're going to we'll do a lot of work with object variables. They're really, they can allow us to do some pretty slick things, and we'll see several examples of them as we go. So if you think, wow, I don't understand object variables, don't drop the class. I wouldn't expect you to understand them right now. I'm just kind of giving you the background that we need. So one other thing here now is to say, instead of object, let me do this. This will seem kind of weird, but let me go ahead and do it. I'm not going to activate that sheet anymore. Instead, I'm going to say set RNG equal to active sheet. Set RNG. ACTIDE sheet. And now I'm going to print RNG.name. Okay, so in this case, I'm binding this onto a range variable, and then I'm printing the address of that variable. And then I'm going to bind it onto a sheet. It seems like weird to set a variable called RNG to a sheet. That's what I'm doing. And then I'm going to print the name of that sheet. So this should print, I'm still on sheet 3. I'm on sheet 1 now. So this should print, it'll print A2, and then this should print sheet 1. So let's clear that off and run it. That's because I said this is data type object, I can bind it onto any kind of object I please. But instead of declaring it as object, I can declare it as range. I can declare it as a particular kind of object. And you'll see that you get some help here. I'm going to hit the space bar and start typing range. I'll go, oh yeah, you might want to make that a range object. So now two wonderful things have happened here. Well, one wonderful, one I'm ambivalent about. The wonderful thing is now that the editor knows that that is going to be referring to range objects, when I type RNG dot, it says, oh, this is a range object. I know what you're allowed to put next. There's a small set of things you're allowed to type after this. I'm going to give you the list. You don't get that help if you declare it as type object. Otherwise, it's the same. I mean, it still allocates enough memory to hold a memory address for someone else. But now two things. Now it knows it's a range object, so it's going to give me the IntelliSense help here. And the other one is, watch what happens if I try to run this. Type mismatch. Let me debug and see where. This is a type mismatch. Because I've said this is a range, this variable is of type range, it is now only allowed to bind onto objects of type range. When I try to bind it onto a sheet, it says, no, you told me this is going to be a range. You are not allowed to do this. It works just fine if it's object, because object is, same thing, just a location in memory that holds an address to somewhere else. And it then can attach onto anything. Okay, again, don't feel too bad if you're like, ugh, I'm totally not fully grasping range variables. One more to talk about. We'll have a lot more practice with that. So the next one is called variant. Variant is crazy. So the variant data type says, I don't know what you're planning to do with this variable, but I'm going to let you do whatever you want. If you treat a variant variable like a string, it will behave like a string. If you treat it like an integer, it will behave like if you treat it like an object, it will behave like an object. This comes at a price. How much overhead is required for string variables? Every string, before I even start storing the string, how much does it take? 4 bytes. To be able to get the flexibility that you get out of a variant type, the overhead for each variable is 22 bytes. Before you start storing any data, 22 bytes just get used for housekeeping on this variable. And so, but you can let this thing do whatever you want. You can set it to a range, set range equal to A2, or you can set it to like a specific value on that range. Just, I want the value of the range. So that would be like an integer or it would be a string, whatever's in that range. If it holds an integer, it'll hold it as an integer. And what will the type be? Well, type will be variant, but it will behave like an integer. If it's a string, it will behave like a string. In fact, it's actually kind of interesting. I think we have the time to see it. Let me just peek ahead and see what else we got going on. Got only one more slide. Okay. So let me just do something with variant here. Let me just come back over here and I'll make a variant example. Subvariant, V-A-R-I-A-N-T. Dim X as variant. Now let me just say X equals range A2. Let me do this. Set X equal to range A2. Now it's going to treat it like an object variable, right? Use that set notation. Debug.print x.address. So that should print A2. All right, now I'm going to take the set off of this. And so now when I run that, this is going to be a problem. I have here a type mismatch. Why did I get down there? I didn't want to be there. That's not the problem I expected. Be on this one and run this one. Object required. So X doesn't have an address. Let me just print it without the address. Let me stop this and go put something in A2 so we can see it. A2 is now holding Nephi. maybe some question you have to answer. Did Professor Allen appropriately bring in gospel topics into class? I'm doing my best here. EPHI. After all, we're studying the Book of Mormon this year. Okay, so now when I run this, it prints Nephi. So what's happened here, because I've treated this as a variant, because X is a variant, when I assign X onto this range, which I would normally expect that would actually connect it up to the range and make it a range object, it says here, oh boy, you didn't specify a property for this range. So maybe I should treat this as an object variable. But when they made the language, the guys at Microsoft were like, you know, working with object variables is kind of complex. And we think the more likely case here is that whoever put this just didn't know they should have said dot value. If they're probably after the value, they're probably not really trying to bind that thing onto an object variable. And that's actually the whole reason why you have to say set in front of binding an object variable on, is because otherwise it's ambiguous. It doesn't know, should we use the default property for this and pull the property's value, or should we actually connect up to the object itself? By putting the keyword set on, now it knows that that's going to be an object variable, and it can bind on to the object itself. So the very reason that you have to say set when you're using an object variable is because of this problem. Variant then, because that variant could go either way. Could be treated as an object, or it could be treated as a variable. So let's do this. Let me tell you why you want to avoid variant. It might be tempting at this point. It might be tempting. Professor Allen, for the past hour, you've been telling us all about these different kind of data types. Why don't you just tell us there's one data type called variant, and we can do anything we want with it? After all, I have 32 gigabytes of RAM. What do I care if I use an extra 22 bytes on a few variables? The answer is you don't really. You're not doing this to save memory. Now, later in class, I'm going to show you how you can create, with one statement, 10,000 variables at once. It's a structure called an array. We'll learn how to do them here. So once you start making lots and lots and lots of variables, the data type is going to be important. But for single individual variables, an extra 22 bytes is meaningless. But here's the reason you don't want to just do things with everything as type variant. Like, the reason you really want to put the data types on is because you're saying, I know what I'm going to do with that variable. And if I do something out of bounds for that variable, don't try to figure it out and just do it anyway. Tell me something's broken here. So for an example, let's just declare some variants. And by the way, if I don't say as variant, like, this is legal. Dim X, that's just like saying as variant. So let me dim X, let me dim Y. Let me say X equals 4, Y equals 3. Now print X plus Y. What will that print? That prints 43. Because these are strings, right? Now, if these were as integer, in fact, if even just one of those was as integer, what would it print? Variables, variant demo. It's going to print 7. So part of the problem here is that once you start dealing with, like, even though I assign this as a string, because I said, hey, I really want this to be an integer, it'll say, oh, you tried to assign a string to an integer, I'll make it into an integer. But you don't get that benefit when you're working with a variant. You just kind of pull it in. And so there's a whole complex set of things that it's going to do when it's trying to decide what to do with variant. And it's not ambiguous, it's clear, it's just complex. There's a lot to know to be able to know how will these variables behave. And you don't want to have to be wondering about how this thing will behave. So set the type that's going to be the type that you know that it has to be, and then that's going to be, you're going to be happier as a programmer. You'll be happier as a beginning programmer. All right. Last screen on this, and these slides are linked from Learning Suite. This is what I want you to know for the exam. Professor Allen, couldn't you have just shown this at the beginning? Because I was taking notes, and maybe I should. Maybe next time I should show this at the beginning, or at least let you know it's here. So, byte, how much memory it takes, and approximately how big it is for these types. And if there's like a data type that's outside of this set, you can pretend it doesn't exist. Like if I give you a list, oh, this data type called character or something, you're going to go, that's not a data type. Quit trying to trick me. It's a trick question, Professor Allen. So you can look at this and say, I want to know these, what is it, 8? These 8 data types, how much memory they take, and about what they can do. You'll notice object is not on this. So I won't give you any question about object on the exam. We'll get experience with it, but not on the exam. Okay, folks, any questions about, oh, there's one more thing I got to talk about. I said any questions, you start packing up, my mistake. Any questions about variables? There's like one more brief idea that we can do in the next minute and a half. And that is, there's another thing that's exactly like a variable that's called a constant. Constants are different. In fact, I can say const pi. Wait, do I say as single? I almost always do it without putting the type because it'll pick the type. Yeah. So instead of saying dim, I say const, but then I have to give it its value right here. Let me print x plus y plus pi. And 0.1415927. Whoa. I didn't expect it to have that on there. It's kind of part of the overhead of being a floating point number. So it's 9.7. Interesting. Anyway, the point I want to make on constant, even though it's not quite behaving the way that I expected it to here, is that you give them their value when you declare them. You have a statement that declares it, and you cannot change it. Like later, if I say pi equals 3.14 and run that, it's like, no, assignment to constant is not permitted. So you give it its value once, and then it sticks forever, like for the rest of the program. So if you've got something you know is never going to change, give it its value up front, let it be, and you're good to go. Okay, that's it for constants and variables. Thanks for coming. I will see you not next Monday. Enjoy your Martin Luther King Jr. Day, but next Wednesday. Class dismissed. Oh, you're too kind. You're too kind. Thank you.